road and rail suspension bridge in the world. With a span of 1,377 meters, it will carry 6 lanes of traffic on its upper deck and 2 rail tracks on the lower deck. As the bridge will be the only highway and railway link to Lantau, the designers made certain it would first provide free access under all weather conditions, second, be protected against collisions by ships, and third, be stable during high winds. Traffic will normally make use of the top deck, but under severe weather conditions, the bottom deck inside the box would be used. Second, the bridge will be protected against possible ship impact. This is why the Tsing Tower has been placed on land, and why the Ma Wan Tower has been located in shallow water, surrounded by an artificial island. Third, the bridge has been designed to withstand the very high wind speeds experienced during typhoon. To make certain of this, extensive wind tunnel tests, 2 huge concrete caissons, which will become part of the foundation for the Ma Wan Tower, were cast on the deck of a submergible barge anchored near Tsing. Both are 28 meters long, 20 meters wide, with one 17 meters high, and the other reparation work of the foundation included underwater blasting to flatten the area on which the caissons will rest. When the Ma Wan site was ready, the 2 caissons on the barge were towed to a site off North Lantau. To protect the tower from ship impact, rock and selected fill material was placed around the foundation of the towers to form an artificial A trial cable compaction for the 1.1 meter diameter main suspension cable was carried out. Once the saddles were installed, the spinning of cables was about to begin. The cables were constructed by the aerial spinning process. The aerial spinning process involved drawing wires from a constant tension supply and pulling loops of these wires from one anchorage to the other. Anchorage to anchorage along the line of each cable. Suspended a meter below the cable positions to enable the workers to form the cables above the Ma Wan channel. This aerial spinning technique dates back more than a century, but this was the first time it has been used in Hong Kong. On a system of pulleys, 4 loops of steel wires were drawn from the Ma Wan anchorage through the saddles, over the tower tops, all the way to Tsing anchorage. For convenience of splitting and adjustment, the cables are divided into 91 strands of 368 wires. The process was repeated more than 8,000 times to form each cable of some 34,000 wires. The cables took 9 months to complete and support the entire bridge's weight of over 50,000 tons. Following the completion of spinning, each cable was compacted into a circular shape and bound with temporary strapping. The cable bands were then fitted, clamped into position by tightening the large high-strength bolts. The suspenders were then looped over them. Each cable measures 1.1 meters in diameter, and the combined length of the steel wires adds up to 160,000. Transporting the assembled deck sections to Hong Kong proved to be a mammoth task. Damage to any part of the assembly from strong winds would have held up the entire process. The barge was moored directly beneath the bridge and and the deck sections lifted into their final position by lifting gantries standing on the main cables. The first deck section took 6 hours to install. The bridge is made up of 95 deck sections, each 1996. The final deck section was lifted and the bridge was inside.
About the same